let's explore the four fundamental forces. The force that we have been familiar with for the longest time is the force of gravity. The range of the gravitational force, that is, the distance over which it can be felt, is infinite. The gravitational force is the one that keeps our bodies onto the Earth. It's the one that holds the stars to the center of the galaxy, that holds our planets around the sun, and that holds the galaxies to each other in large clusters of galaxies. So it extends over the range of the universe. As we go into increasing strength of the forces, the next force is one that we call the weak force. Now its range is 10 to the minus 18 meters. That's 1, a decimal point with 17 zeros and a 1. So it's an extremely short-range force, and it was the one that was most recently discovered around 1930. About 150 years ago, we discovered the electromagnetic force. That is the force of electrical charges and the force of magnets as well. Now its strength and range, its range is also infinite. It extends over the entire universe, and it is composed of two types of forces that are really unified. The first is the force between electrical charges, which come in two types, plus and minus, and like charges repel and opposite charges attract. And then we have magnets that occur in pairs also, in poles, north and south, with similar attractions and repulsions. And this was developed about 1850, 1875 in that region, and it gives rise to our familiar electrical devices, such as the camera that's recording us right now, that we've come to depend upon so well. It is our everyday force at this point. The force that was discovered around 1910 or so is called the strong force. It is the force that holds the particles inside a nucleus together, and its range is around 10 to the minus 15 meters. It's also a very, very short range force. Now, if I examine the comparative strength of these four forces, if we give the strong force a strength of 1, then the electromagnetic force is 130 times smaller. And the weak force is 10 to the minus 6 times smaller than the strong force, and the force of gravity is 10 to the minus 40 times weaker than the strong force. Now, the force of gravity, even though it dominates our everyday life so much, is by far the weakest of these four forces. And I'll illustrate that to you right now. Here I have two objects, and each of the two objects has a mass. And since mass exhibits gravitational attraction, these two objects attract each other gravitationally. But as you see, the gravitational force is nowhere near strong enough for them to stick together. However, in these two objects are also some magnets. Now, if you observe, the magnetic force is much, much stronger on the same size object than is the gravitational force, and certainly enables them to stick together. So the electromagnetic force is tremendously stronger than the gravitational force. The only reason that the gravitational force is visible to us is because our objects, such as our Earth, our Sun, and even our human bodies, are so huge that when you get this much mass together, it does accumulate a large amount of gravitational forces. But if you go into the world of elementary particles, then the gravity of a small particle, such as a neutron or electron or a proton, is so insignificant because of the very, very small mass of the particle. But the electric charge of that particle can be very, very strong. So electric charges are extremely dominant over gravitational forces when we go down into particles. Now, lately, even the strong force, which is sometimes called the strong nuclear force, the force that holds protons and neutrons together inside of a nucleus, is so much stronger than the electromagnetic force that it overpowers it. But notice, it's a very short-range force, so the two particles have to be extremely close together before it kicks in. Inside the nucleus, you can have two protons, each of which carries a charge of +1. And because of the electromagnetic repulsion of those electric charges, they would want to fly apart. But they are bonded together because of the overwhelming strength that each one of them also feels a strong force for each other, which is 137 times stronger than the electromagnetic force. If you want to get a picture of what it means for a force to be 137 times stronger than another force, think that you may be able to lift 100 pounds. But if your force was 137 times that, you would be able to lift 13,700 pounds, a significant difference.